Already completed the etcd cluster setup. Now let's move forward for the Kubernetes control plane setup. That means the controller components like API server, scheduler, and controller manager configurations. So for that, first we need to just create a Kubernetes configuration direct. It will be under etcd etcd/kubernetes/config, and we need to create or execute commands on both the side, which is master 1 and master 2. Okay, so the next step will be downloading and configuring the binaries from the official Kubernetes website. Okay, and this will be the command. So we will be downloading Kube API server binaries, Kube controller manager binaries, Kube scheduler binaries. These three are the master components. We also call it controller components. And kubectl is the command line utility, as we already discussed. So it will take some time, and the download depends upon the network bandwidth. So I just use the same command to download all those binaries. So now we can see these all four components are downloaded successfully. And let's check the status on master 2 nodes. Yes, we got those components downloaded in master 2 as well. I'm just checking the directory and I can see uh, the components are downloaded here as in files. Okay. So next step, what we have to do is we have to install these downloaded binaries. I'm just assigning them to the executable permission at the first place on both of the nodes. So I'm using chmod command and adding the executable rights. And same command I will use for master 1. And now I'm moving these binary files to the user local bin directory. Okay, and this will be executed on both of the servers. Cool. So the next step will be configuring the Kubernetes API server first. So for that, what we have to do is we have to create a directory and copy the appropriate certificate and configuration files. And this will be the command to do that. So let me make that in a batch. So this will be the command, making a directory and copying these many configuration key files and certificate files to this location, varlib Kubernetes, and same in master 1. Okay. So in this, as we already discussed, the instance internal IP address will be used to advertise the API server to its member inside the Kubernetes cluster. So just to retrieve the internal IP, we again have to use the same command. We have to define a variable value, which is internal IP like this, and it will be assigned the nodes or machines internal IP. And if in cases we have to verify like what is my internal IP got assigned to this variable, we can just simply echo that, and it should give us the output like this. So this IP address depends upon your virtual machine setup. So in my case, I'm using 192.168.5.3s. Okay, so let's move forward and just create the Kube API server systemd service. And for that, this will be the configuration. And you will notice we are using same configurations which we generated in our previous step, like what is our etcd server clusters, what is the certificate files for etcd, and the same API server certificate and keys. So all those certificates we are using here. We just need to hit enter, and same service needs to be created on master 2 as well. So now we have the Kubernetes API server systemd service, and same way we will create the controller manager component. So for that, I just need to create copy the binaries for this controller manager to the varlib Kubernetes directory where we are storing all the Kubernetes components. And remember to execute in other node as well. And this time we just need to use the same configuration file to create the controller manager component systemd service. So here we are using the cluster CIDR value, service account, service key, which we have created in our initial steps, assigning the cluster IP range and service account credentials to true. So these are the default values. Done. And same needs to be done by master 2. Okay, so let's move forward, and the next component will be kube scheduler. Same step, copy the binaries to the appropriate directory, which will be Kubernetes, varlib Kubernetes, and same here. Okay, so now generate the systemd service from this configuration. This is our localhost address. So this will be our configuration for creating the systemd service, which will be called kubescheduler.service. Just hit enter. Same steps needs to be followed on master 2. Okay, so from our last 3 steps, we created a service for API, we have created service for kube scheduler, we have created service for controller manager. So now time is to start and enable those systemd services. So I will create a batch of commands and combine them to execute together. So just sudo systemctl daemon reload to reload the configuration, systemctl to enable the service, and systemctl start to start the systemd services. And same we need to execute here in the different master. Cool. So just to verify, like if our components are deployed properly, are responding correctly, so we can just use this command to check our controller manager components health. It will take some time because those services are being loaded, so you have to wait for a couple of minutes and it should return the value. There we go. So we got scheduler health, okay. We got controller manager health, okay. We got 2 components, etcd1, etcd0, health true, and that is the expected value. So we have successfully installed the controller manager components till now. So next step will be installing and configuring the load balancer. We do have a load balancer machine specifically for supporting the network load balancing capabilities. So for that, we have to just log into the load balancer node using SSH terminal. I have already logged into that node. So in that node, first we have to download the binaries for load balancing software. I'm using HA proxy in our case. So the command will be like sudo apt get update, sudo apt get install HA proxy. So it will take some time. So this HA proxy will provide load balancing capabilities. We will use its address to while we are using the administrative console capabilities. We are not using the dedicated those commands dedicatedly to master 1 or master 2. Instead, we will use the load balancer, and it will randomly redirect our request to master 1 and master 2 based upon the round robin algorithm. So it is currently downloading those packages. Okay, so now we have the binaries downloaded for HA proxy into our load balancer virtual machine. Now we have to set up the configuration so that this HA proxy component will distribute the load between our master instances, which is master 1 and master 2. We'll create one configuration file called haproxy.cfg, and for that, this will be the command. This will be the command to create this file haproxy.cfg. We're binding this IP, listen IP for front-end Kubernetes belongs to uh, load balancer, and it is the backend server will be our master 1 and master 2 servers. So we'll create, file got created, and we just need to start the HA proxy service, and this will be the command sudo service HA proxy start. So that is all, and let's use this load balancer IP to check the Kubernetes version, and let's see if it is responding, because it will fetch that information from master 1 or master 2, and we got the value. So by this step, we have done with our controller components installation and configuration. In our next section, we will move forward with the worker node installation and configuration. Till then, stay tuned.